All right, so go ahead and read problem 6 to yourself. This is the classic example of seeing a straw in a glass of water and the straw appears broken, bent in some way, right? Have you all seen this example before? If not, well, go get a glass of water, put a straw in it, and look down at it. You'll see an image like this that even though the straw itself is not bent, it appears bent. Obviously, this is because of the refraction of the light. So the most important part here is drawing a good picture. So why don't you go ahead and try to draw the picture of the situation, what's happening here, and see how I do it. We'll start with our usual boundary and normal. Remember, of course, the normal is drawn as a dashed line because it's imaginary. This is going to be the boundary between air and water. And let's put the straw in the water, and you are looking at it. Of course, you are going to be in the air. So let's draw your eye over here. Now, if you didn't draw something like this, you want to change your drawing a little bit so we can compare it to what I'm doing here. Now, the most important part of this drawing is which way the light's going. So if you are seeing the straw, does that mean that light is going from the straw to your eye, or from your eye to the straw? Pause the video, think that through, draw what you think is happening. Hopefully you realize it's that light is going from the straw to your eye. It's not like we see things by shooting light out of our eye, right? No, that's not what happens, right? We see things because light comes to us. So we want to draw the light going from the bottom of the straw to our eye, which means it's going from the water into the air. Now you think to yourself, as light goes from water into air, is it speeding up or slowing down? Of course, it's speeding up. Air is less dense, there's fewer things in the way, so it's speeding up there. So does that mean it's bending towards the normal or away from the normal? This is bending away. So we want to draw a ray of light that starts at the bottom of the straw, goes up towards the water-air boundary, and then bends away from the normal to go into your eye. So go ahead and draw that. It should look something like this. Again, going up to the connection point here, and then bending away from the normal in the air, going into your eye. This is the ray of light you are using to see the bottom of the straw. All right, now we have to put the 56-degree angle in there. It says that we're looking down at an angle 56 degrees below the horizontal. So let's say there's the horizontal. Where's the 56 degrees? That's going to be over there. That's what it means when light, we're looking down at 56 degrees below horizontal, the light's coming towards us at that angle. All right, so the question is asking, where would you be, or where would your eye be if there were no water? If the light were just going to go in a straight line, which means your eye would be somewhere up here. Obviously, we're going to be using Snell's law to figure this out. We just have to identify where's theta 1, where's theta 2. Well, here's where the arrows really matter. The light is starting in the water, going into the air, and angles, of course, always measure from the normal. So theta 1 is the angle in the water, theta 2 is the angle in the air, because it starts in the water, that's medium 1, it ends in the air, that's medium 2. So we're going to use Snell's law, n1 sine theta 1 equals n2 sine theta 2. What are we actually solving for here? Well, again, we're trying to see what would happen if there were no water in the glass. So if the light were starting here and it would just go in a straight line because it's just air, that means our eye would be up here and we'd be able to look down at this angle and see the bottom of the straw. So really, we're looking for theta 1, the true angle that the light makes with the normal. All right, so pause the video, go ahead and solve for theta 1. Obviously, we're going to rearrange Snell's law to solve for theta 1, but what's theta 2? Well, hopefully you realize it's certainly not 56 degrees, right? Because that's this angle over here. Just imagine a right triangle. What's theta 2 going to be? It's going to be the complement. It's going to be 34 degrees. So you can see clearly I really didn't draw this very much to scale, but knowing, ahead of time I didn't know what the angles would look like and all that, so it's just a representation of what's happening. All right, so you can put 34 degrees in for theta 2. N1, of course, is going to be the index refraction for water, N2 is index refraction for air. You should have no trouble getting 24.8 degrees, and we box that in as our answer. Okay, so that's the true angle the light makes with the normal, and then it bends away from the normal, so the 34 degrees to go to your eye. So what are the consequences of this? Why do we see the straw bent? Well, when it comes to light, it turns out, humans are easily fooled. We're kind of stupid when it comes to light, even though from our perspective we can see, we know in the physics, that the light is going to change direction when it goes from the water to the air. when we see the light coming towards us, we have no way of conceptualizing that. There's no way we can figure out, oh, the light's changing direction. Where's it really coming from? We just see the light coming towards us, right? And so if light is coming towards your eye at this angle, your brain naturally traces the light ray backwards because we think light comes to us in straight lines. That's the only way we could ever think about it. And so if we think the light comes to us in a straight line, that means we see an image of the bottom of the straw here. And so the whole image of the straw is bent upwards towards the surface. This is the classic example of the straw looking bent underwater or looking larger because it's closer to the surface. And our brain naturally interprets larger as being closer. So it looks like this, right? And so this is the explanation of why we appear to see the light, the straw bent, because of the refraction of the light. Now it goes the other way as well. Let's say there was some, I don't know, like a bug on the bottom of the straw, and it was looking up through the water at your eye. Well, bugs, just like humans, are kind of stupid when it comes to light, and they think light comes to them in a straight line. And so the light would follow the exact reverse path. It would go from your eye along this path, bend towards normal, going towards the bottom of the straw. And so the bug looking up would see the ray of light coming along this path towards it. It would naturally trace that light ray backwards into the air. It would see an image of your eye over here. And if you've ever been, underwater in a pool, looking up through the water at people on the side of the pool, right? That's what it looks like. It looks like everyone is farther away. Everything looks taller, farther away from where you are because of the refraction of light the other way. Whereas if you're in the air looking down through the water, everything looks closer to the surface.